Okay, a few problems to help review for next week's quiz. First, the 45-45-90 triangle theorem. Theorem states that the length of the two legs are always equal, so we'll call each side x, and the hypotenuse is that number times the square root of 2. So, a few basic problems to start. We have if a leg is equal to 4, the other leg is equal to 4, the hypotenuse is that number 4 times square root of 2. Simple as that. If we change the length of the leg to equal, say, 5, the other leg is 5, and 5 times square root of 2 is the length of the hypotenuse. And if we have the length of a leg is equal to, say, something like 10, the other leg is 10, and 10 times square root of 2 is the hypotenuse. And we can reverse the steps. If the length of the hypotenuse is 9 times square root of 2, the length of one leg is equal to 9, and the other leg is equal to 9 because we took the hypotenuse and divided it by the square root of 2. Square root of 2 canceled in both the numerator and denominator, and that's how we came up with 9 for the length of the two legs. And if we were to do another problem, if the length of the hypotenuse is equal to 12 times square root of 2, then the two legs are each equal to 12. And one slightly more challenging question, if the length of the hypotenuse is equal to 8, we have to take that number and divide it by the square root of 2, and that's the answer for the length of each leg. But it's not simplified, so we're going to multiply by the square root of 2 over the square root of 2, and we get 8 times square root of 2 over 2. 2 goes into 8 4 times, so we get 4 times square root of 2 for the length of the leg at the bottom, and the same for the length of the leg on the other side. Next theorem we're going over, 30-60-90 triangle theorem. That theorem states that whatever the length of the shorter leg is, the shorter leg always opposite the 30-degree angle. So whatever that length is, the hypotenuse is 2 times that number, and that number times square root of 3 gives you what's called the longer leg. It's opposite the 60-degree angle. So a few problems dealing with this. If the length of the shorter leg is equal to 2, the hypotenuse is 2 times that, which is 4. The longer leg is 2 times the square root of 3. If the length of the shorter leg is equal to 3, 3 times 2 or 6 is the length of the hypotenuse, and 3 times square root of 3 gives you the longer leg. And if the length of the shorter leg is equal to 4, 4 times 2, 8 is the hypotenuse, and 4 times square root of 3 is the longer leg. If the hypotenuse is given as equaling, say, 10, if we multiply by 2 to find the hypotenuse, we divide by 2 to find the length of the shorter leg, and therefore that number, 5 times square root of 3, gives you the longer leg. If the length of the hypotenuse is equal to 9, we divide that by 2 and we get 9/2 for the length of the shorter leg, and that number times the square root of 3 gives you the longer leg. And continuing still, if the longer leg is given as equaling, say, 7 times square root of 3, you divide by the square root of 3 and you get 7. That's the longer leg divided by the square root of 3 gives you the shorter leg. The square root of 3 factor cancels, and we get 7. 7 times 2 or 14 is the hypotenuse. One more problem. If the longer leg is equal to, say, 12, we have to divide by the the square root of 3 to find the shorter leg, so we take 12 and divide it by the square root of 3. That's not simplified, but that is the answer. It's multiplied by the square root of 3 over the square root of 3, and we get 12 times square root of 3 over 3. 3 goes into 3 once, 3 goes into 12 4 times, and we get the length of the shorter leg is equal to 4 times square root of 3. That doubled, or in other words, 8 times square root of 3 gives you the hypotenuse. And an excellent problem, putting the last couple of chapters together. We have the ratio of the two sides of a new TV is 16 to 9. If the diagonal of the TV is 50 inches, find the length of the longest side. Okay, so we have a diagram of the rectangle representing the screen of the television. If the ratio is 16 to 9, the sides can't be 16, 9, and 50 for the triangle that I'm looking at, this right triangle, because the hypotenuse wouldn't be 50 if the two sides were 16 and 9 respectively. But the two sides can be represented as 16x and 9x, indicating that we have a common factor that was canceled to reduce the ratio to equal 16 to 9. So now we have a right triangle to look at. We can use the Pythagorean theorem and say 9x squared plus 16x squared, we need the 16x and the 9x inside parentheses, equals 50 squared. And we have 81x squared, 9x times 9x equals 81x squared, plus 256x squared equals 2,500. We simplify, we have 337x squared equals 2,500. We divide each side by 337, and we have x squared equals 2,500 over 337. And we'll take the square root of each side of that equation. And we have x equals the square root of 2,500 over 337. So we'll get an approximation for that by using a calculator. So we have the square root 2,500 over 337 equals approximately 2.72. So going back to our problem, we have x is approximately equal to 2.72. But that's not the answer to the question. We have to plug in 2.72 back in the original diagram. We're only looking for the length of the longer side, so therefore we have 16 times that answer. So therefore, going back to the calculator, why don't we just take that answer times 16, and we get an answer of approximately 43.58. So the answer to the question is equal to 43.58. Hope this quick review helps you for tomorrow's quiz, and good luck.